flat to block out, and maybe there'll be a turned edge, a quarter of an inch wide, which will reduce the aperture to say around 19.5 inches. And then this is getting stiff again. I think I'm going to have to add some more water before long. Let's say that the actual aperture is 19.5 inches if I mask off a turned edge. And then there's a center area 8 inches wide in the mirror that I can't figure accurately. Well, all I have to, the focal ratio is f7, which is it's about 135 inches. So as far as I could tell, I haven't actually measured it with the focal test yet, but that's roughly what it is. From measuring the curve in rough grinding with that depth method with the drill bits and the straight edge, all I have to do is polish an 8-inch optical flat or a large Cassegrain secondary to fold the light path down to where the eyepiece is at a convenient position near the ground, and mask off the turned edge. And let's say I have an 8-inch flat. Subtract that 8 inches from 19.5 inches, and that means you end up with an equivalent diameter for looking at delicate planetary details. 19.5 minus 8 is 11.5. My telescope, 20-inch telescope, will work exactly the same as an 11.5-inch unobstructed reflector with perfect optics as far as looking at the planets, which is about what the Earth's atmosphere usually limits you to under quite good seeing conditions. So you'd really never even notice optically a flat mirror that large blocking out the center of the primary, except you'd have a little bit of light loss, about maybe 16 to 18% light loss, which you probably wouldn't notice either. That turns out to be, I figured that maybe somewhere around 22% light loss, counting the extra reflection I would need, because you'd have to have 3 mirrors if you do that system. And not a good idea to enhance coating, do enhanced coating on large, delicate precision optical surfaces like a 20-inch mirror or an 8-inch optical flat, because the mirrors have to be heated up to a quite high temperature when you coat them, and that could distort the surface slightly. So I figured that you lose somewhere between decimal 2 and decimal 3 magnitude in limiting magnitude power by doing that. But then you'd end up with a much more accurate optical system without any bad zones that'll create bad star images. So and then you'll also have a more convenient eyepiece position. But this is all conjecture on my part so far. I'm just not sure exactly what I'm going to do, but there's all kinds of possibilities depending on how accurately overall I can figure this thing. Right now it's getting pretty stiff again, getting real hard to move. So right now I'm not going to take any chances. I'm going to add a little bit more barnsite and water. It's quite a job. I'm going to add a little bit thinner mixture of water this time. I'm not sure where you can buy barnsite now. I haven't really checked the ads for telescope making materials because I had enough of them left over from my other projects years ago that polishing agent, as you can see, it doesn't get used up very quickly. It really doesn't. You can get this. There's probably enough in this jar to polish another mirror this size without any trouble. But I'm going to save it in case I need it for an optical flat or something like that, a large optical flat, or to do some corrections on this mirror or something like that. It's not a good idea to just throw your polishing agent out when you're through with it. That jar has been in that shape, just like it is, since I ground my 26-inch mirror years ago. So now I got to break this in a little bit again. There. Just with a few short strokes just to get her started. I think in a minute, I think I've talked about all I want to talk right now. I'm starting to bore people, I think, but by the way, I should mention something else while I'm chugging away here, and that is that if this mirror turns out to be incredibly accurate from virtually the center of the mirror to almost the edge, with really hardly any measurable aberration at all, and all the, like Texero says in his book, if all the rays from all the zones on a ray trace of the actual optical face, like from the Texero's testing method of zones with the focal test, if all those rays intersect within within the diffraction disk radius, meaning it's virtually a perfect optical system, and then if I want to have an image down near the ground to look at the planets, I can give you this piece of advice. I don't know whether it's a good piece or not, but I think it is. A Gregorian secondary would be much easier. A secondary mirror, like around 4 inches across, would be much easier to figure, most likely, than a Cassegrain secondary. It just would make your tube a little bit longer, and your focal ratio a little bit longer. Well, I have a 4¼ inch piece of Pyrex, a blank, and I was thinking of grinding a Gregorian secondary, which would make this into about an F50 telescope for planets. And the image would be right down near the ground when the telescope was aimed overhead, which would be very convenient to use from a standpoint of comfort for the observer. And also, the Gregorian secondary is an ellipse. So you can have a pinhole source of light at the focus of the Gregorian secondary that's closest when you're testing it, that's closest to the mirror, and then you have a knife edge, like a razor blade, for testing it at the far focus. And you just keep figuring the 4¼ inch, just like you would an ordinary mirror in your basement, until you get a perfect null test with the pinhole which at the one focus and the knife edge at the other. And then your thing is, the mirror is figured perfectly then. And then it gives a real good image automatically at the final focus. You don't have to worry about figuring. The convex mirror is much more difficult. There's ways of doing that in Texro's book, but they're all very, very nasty to try and get an accurate, smooth surface on it optically. So I would recommend, if you want a really superb planetary telescope with a large primary mirror, if you can get away with it, if you have enough space that you're observing, well, you can use a collapsible telescope tube, which is what I might do. One that folds up, sort of slides together when it's not being used for storage. Just slide it apart when you use it. Is to use a Gregorian secondary. Actually, that's not my own idea. I saw that in Sky and Telescope once by a guy who did it. Sort of a semi-professional optician who made I think it was a 6-inch Gregorian or 8-inch Gregorian that way. And he said it was much easier than making a Cassegrain secondary, and gave very nice results of the planets and moon. And very, very easy to figure by comparison. And Texro says in his book that the primary difficulty with figuring a Cassegrain secondary is that there's no way of directly testing the accuracy of the curve on the convex Gregorian secondary surface. So, of course, this is all assuming that your primary mirror is very good. If your primary mirror has a few minor defects in it, especially of shallow slope, that is, there's no severe little rings and stuff in it, or zones of abrupt slope change, then you can compensate for those to a large extent by figuring it against the star image with the Cassegrain secondary. You can actually figure the secondary right in the telescope tube. You could use a Ronchi test to get it fairly accurate, right on a star in the sky with a clock drive running. And if you want to do the focal test, you use an integrated method with a digital camera, with say a 15 or 16 second exposure, and that'll even out all the irregularities caused by turbulence in the Earth's atmosphere. And you can get a nice accurate way, overall optical system that way. You can null figure it that way because you're figuring on an actual star, where you want all the rays to intersect at the right spot and the mirror to darken evenly under the focal test. By the way, I'll be focal testing this when I'm finished. I'll try and give you a look at some of the zonal, with the video camera, with my digital camera. I'll give you a look at actually what it looks like under the focal test to see the zones darken evenly on both sides and stuff like that when you reach the right spot in the figuring. And I'll try and show you some of the figuring strokes if I can. I can't promise that though, because the figuring strokes are so nerve-wracking sometimes that I don't think I can stand to have the video camera running while I'm doing it. But I can describe to you anyway later how they work. I can't believe I've been talking away and polishing for about an hour now, according to my clock. I can't believe the time has gone by that quickly. It's been I hate to say this, but polishing this mirror today is a real barrel of laughs. Barrel of laughs. I have to get at least one bad joke in my work. So polishing on this barrel is a barrel of laughs. There we go. I guess you notice I'm starting to get slightly out of breath now. It's not exactly as bad as running a marathon, but it is physically fairly demanding to do this. I guess I mentioned not to worry about my old clothes. These are really, really bad clothes in terrible shape. Now it's stiffening up real bad, so after this little session I'm going to add some more polishing agent. As soon as I do that, I'll shut the camera off. The pitch squares are still in really good shape. I may trim them again before I start polishing with rouge, just to eliminate the, there's a little ring of barnsite around each square. I don't know whether you could see that in the video or not. You'll probably see it in some of the still photos too. Just a little ring of polishing agent around the edge of the facet of the square. And if I trim that off, then when I start using the rouge will form that little ring instead of the barnsite. So I won't be getting barnsite mixing in with the rouge maybe quite as much as I would have if I just started adding the rouge to the tool. But that's just conjecture. I don't know whether that'll happen or not. But I don't like to trim this thing any longer than I have, any oftener than I have to. I think I would probably just go ahead and figure with the rouge without doing that. I'm just going to add a little, scraping the bottom a little just to give me a little bit thicker of mixture of barnsite and water, since I've probably nearly finished the polishing anyway. It's going real well today. After I get this broken in for a few more seconds, I'm going to shut the camera off. Save my last videotapes for, pardon me, save my last tapes for showing what I do during the figuring operation. Isn't this fun? I just love doing this. Break it in with a few nice short little strokes. Just loads of fun. I'm going to have to start doing exercises after I finish this mirror, because you sort of get feeling good after you've had a workout. You know, I guess it's, what is it, endorphins or something? And if you get in good physical shape, it actually makes you feel better overall. Like you're, better feeling about your health and all that. And so I'm going to have to start doing push-ups and chin-ups and sit-ups. And I do sit-ups now already, but all kinds of exercises just to keep in shape when I finish this, just to maintain the level of physical fitness I'm getting from making this large mirror. It's really amazing how powerful. Of course, I've got a sore shoulder and arm a little bit from polishing it because of the jerky action on the ligaments and all that. But still, I think it would be a good idea to keep exercising after this. I'm trying to center the mirror fairly well. I'm just going to go over and turn the camera off now. Thank you very much for your indulgence. I think that all this has worked out real well. So anyway, I'll probably see you during the figuring process sometime. Here we go. Hello, we're recording now. I'll be right here. Just a minute. Tape is running, so I better run too. Okay, what I'm doing now is I'm doing the figuring on the mirror. I'm going to take this mirror, the 20-inch mirror, and put it over on the barrel. I've got a slight case of the flu today. It's not too bad, so I'm going to persevere and try and I'm just turning the little clamp that holds it into place. And now I'm going to take the mirror and move it over to the barrel. As you can see, there's layers of paper here. You can see the red rouge stains in the paper from when I polished with the rouge last time. I've used rouge just once on the thing so far. I think I'll put the mirror on first and then tell you what happened. Trapping my fingers underneath the edge. Here it comes. Ah, there. Now what I'm going to do is, you might be able to see the rouge stains running down the edge of the